During the fractional distillation of turpentine, 2 years later, he archived a heavy implementation of the acrylmethyl distillation and obtained a small proportion of special compute with two halogen atoms. A few months later, another researcher carried out a similar investigation. Common name and formula EUPAC, also known as 2-methylpropene or 2-methyl-1-propene. The EUPAC nomenclature of the compound, commonly called isobutene, is 2-methyl-prop-1-ene. We have two properties: physical and chemical. Physical state is a colored gas at room temperature. Boiling point approximately 6.9 Celsius, melting point approximately 140 Celsius. Density: it has a density of 0.62 at 20 Celsius in the gaseous state. Solubility: is insoluble in water, but is soluble in non-polar organic solvents, such as ether and the chloroform. The structural characteristic the isobutyl molecule in Spanish is this. Well, the structural characteristics of the isobutene molecule, the molecular formula is this: C4H8. In isobutene, the central carbon atom C2 is bonded to a methyl group CH3 and has a double bond with another carbon, C1, forming a bridge alkene. Electrophilic adhesion reactions that isobutene include hydrohalogenation. Isobutene reacts with halide acids in addition reaction following Markovnikov's rule. Example: addition of hydrochloric acid to isobutene produces 2-chloro-2-methylpropene. Here we visualize the molecule in 3D. Chemical is a fundamental component being the skeleton of essential compounds such as glycerol, isopropanol, and butyl rubber. In organic chemistry, a molecular structure is composed of a set of atoms linked together to form molecules. The chemical bond or chemical union occurs between two or more atoms to establish an association mediating attractiveness between electrons, generally the variable number of the electrons in the outermost layer. Step 1. Formation of the carbocation intermediate. Hydrochloric acid is a polar molecule, where a hydro is the positive pole and chloro is the negative pole. As hydrochloric acid approaches isobutene, the double bond of isobutene reacts with the proton of hydrochloric acid, which is the electrophile in this reaction. The electrons from the double bond are transferred to the proton, forming a CH bond at the C1 or C2 carbon of isobutene. This addition generates carbocation intermediate at the carbonyl that did not bond to the hydro, and this intermediate is stabilized by the surrounding alkali groups. Through the Markovnikov's rule, the proton preferentially binds to the carbon with the highest number of hydro atoms, C1, forming the most stable carbocation, which in this case is the tertiary carbocation at C2. Second step: attack of the chloride ion. The chloride ion, which is a nucleophile generated after this dissociation of hydrochloric acid, approaches the tertiary carbocation and attacks the positive carbon. A bond is formed between the carbono and the chloro, resulting in addition product of terbutyl chloride, 2-chloro-2-methylpropene. Finally product 2-chloro-2-methylpropene. The result of This reaction is the compound 2-chloro-2-methylpropene, which a tertiary alkali halide. This electrophile addition reaction is a classic example of the addition of hydroxylic acid to, to an alkane, where the electrophile binds following Markovnikov's rule.
Usetinol dehydrations. This reaction converts usetinol into usetin in water. Usetin dehydrogenations. This process releases hydrogen and converts usetin to busetin. By process making possible to bind to busetin effectively and in large volumes. With this cruising to make is the mean in the petrochemical industry, where it is used the production of isentin rubbers such as ductin and polysulfame. Application and use both in everyday life and on industrial level. Using is intercurrent with various applications in industry and everyday life. Tend to use structures that follow multiple use. Some of them are 1. Chemical industry in place in production. 2. Films in habitats. 3. Pharmacochemical industries. Using has a moderate but significant and environmental impact, especially because of its contributions to our improving in smog. However, its relative harsh life in the atmosphere reduces its persistence. How is it still necessary to properly manage in control emissions to minimize its environmental effects?